Hello everyone, welcome back to Infinity Plus. In our previous session, we have laid a groundwork by understanding the core concepts of linear programming. We have understood the definition of linear programming, objective function, feasible solution, and also we have solved examples separately based on maximizing the objective function. Now, in this video, we are going to solve for both maximum and minimum values within the same problem. Next sum, we will be having the same problem but we are having as a minimize. So what they have given, minimize z is equal to 3x plus 5y subjected to constraint x plus 3y is greater than or equal to 3, x plus y is greater than or equal to 2 and x comma y is greater than or equal to 0. So these are the two constraints and this is the non-negative constraint we will be having. So take up both the constraint in the separate manner. I have taken 3x plus y is equal to 3. So I have written the inequality as a equality in direct sense. So substitute the values and find the solution for the line. For x is equal to 0, we will get 0 plus 3y is equal to 3. So y value we will get it as 1. For if I am giving y is equal to 0, we will get x is equal to 3. So the solution box we will be getting it as x and y. If x is equal to 0, y will be 1. If y is equal to 0, x will be 3. In a similar manner, solve the other constraint which will be having as it is x plus y is equal to 2. If x is equal to 0, y value will be getting it as 2 and if y is equal to 0, x value will be having it as 2. So the solution box is, if x is equal to 0, it is 2 and if y is equal to 0, we will be having x value as 2. Now let's plot the graph for both the constraints. So we have taken a Cartesian plane having x-axis and y-axis and I have taken the scale as 2 cm is equal to 1 unit for both the axes. Now let's plot the graph for the first constraint, that is we will be having x plus 3y is equal to 3. And this is the table for x plus y is equal to 2. So let's plot for the first one. That is, we will be having 0, 1 as the first point and 3, 0 as the second point. First point, that is 0, 1. That we will be getting it as here. Next we will be having 3, 0 which is this one. So now join these 2 points to form a line. So this is the graph for the first constraint. Next plot this second constraint in order to get the another line. So we are having 2 points as 0, 2 and 2, 0. 0, 2 points we are having here and 2, 0 is this point. Now join these 2 points to form a line. So these are the 2 lines for both the constraints. So this is the constraint for the line we are having x plus 3y which is greater or equal to 3 and we are having the second one, that is x plus y which is greater or equal to 2. The solution area for each line. We are having first line as x plus 3y greater or equal to 3. So since we are having the symbol greater than or equal to, we are having the solution as the upper portion of the complete line as the solution. So this is the solution for the line x plus 3y is greater or equal to 3. For the second line x plus y is greater or equal to, we will be having the solution as the upper portion of this line, this one. Now where these two are going to meet? Yes, obviously if we are going to take the solution area, so this is the feasible region or the region where both the lines are meeting each other. So this is the feasible region. If we consider both the non-negative constraint as x greater or equal to 0 and we are having y greater or equal to 0. So this is the feasible region we will be having. We people are well known that the solution for the LPP can be found at the corner points. So solution can always be found in the LPP in the corner points. So what are the corner points you are having for the feasible solution? This is the first point. This is the second point. I will be taking it as B. And the third point is not this one. Please note that this is this point. which is C. So what are the coordinates of the point A? A point is having the coordinate as, we will be having 0, 2, and B point is having the coordinate as, you can see from the graph, it is, you can observe the coordinates of the point B. So for the x-axis, the value you will be having in between 1 and 2. So we can take it as x-axis is 1.5, comma, and for the y-axis we will be having between 0 and 1. Between 0 and 1 means we will be having 0.5, and C coordinate we can get it easily as 3, 0. So let's find the minimum value for this objective function using these points. So this is the table, we have got it for the points A, B and C and the objective function, that is 3x plus 5y. Now substitute all the points in this objective function and get the value. If we substitute point A, that is 0, 2 in this objective function, we will get the value as 10. And let's substitute the point B 1.5, 0.5 in the objective solution. Let's substitute it here, that is 3 into 1.5 plus 5 into 0.5. We will get the value as, that is 7. So we will get objective solution as 7. Next, substitute the C point, you will get it as 3 3s are, that is 9. Now, in the question, they have given to find the minimum value, but not the maximum value. So, what is the minimum value you will be having? So, this is the minimum value, that is 7. We are getting it as Z minimum, which is equal to 7. At a point, we are getting it as B of 1.5, 0.5. So this is the solution for the minimum. So let's jump right in and solve our first LPP, which is having both maximum and minimum solution in the same. So let's start with an example. We are having solve the following LPP graphically. They have given maximize and minimize. So what you have to do? You have to find the maximum value and also you have to find the minimum value for the objective function they have given. So this is the objective function which we have discussed earlier. Now subjected to constraint they have given, and also we are having non-negative constraint x comma y is greater than or equal to 0. So let's solve this sum. So let's solve this sum easily. So first let's take up both the constraints separately. First I will be taking the first constraint. Again I have converted the inequality symbol into equality symbol in order to find the solution for these graphs. So I am taking x is equal to 0. We will be getting 0 plus 2y is if I substitute it in this equation. So we will get 2y is equal to 10. So y value we have got it as 5. So now put y is equal to 0. What you will get? You will get x is equal to 10. Now the solution box we will be getting it as x and y. If x is 0, we have got y as 5, and if y is 0, we have got x value as 10. In a similar manner, let's solve the another constraint. So second constraint we will be having it as, it is 3x plus y is less than or equal to 15. So we will write it as 3x plus y is equal to 15. Now give the values for x and y. Now let's draw the graph for both of these constraints in the graph sheet. So we have taken a Cartesian plane having x-axis and also the y-axis. With the scale in each centimeter, I have taken it as half unit. So half centimeter, I have taken it as 1 unit. So now let's put the graph for each constraint. So this is the first constraint table and this is the second constraint table. So first plot the first constraint table. We are having the coordinates as 0, 5 and 10, 0. So we will be plotting first 0, 5. 0 on the x-axis and 5 on the y-axis. So we are having a point here, and next point is 10, 0. So 10, 0 will be having on the x-axis this one. Now draw the line by joining these two points. So this is the graph of a line. We are having x plus 2y is less than or equal to 10. So now let's plot the graph for the second constraint. We are having the coordinates 0 and 15, and also the 5 comma 0. So 15 comma 0 we will be having it. So let's plot the graph for the second constraint. We are having the coordinates as 0 comma 15 and 5 comma 0. So 0 comma 15 is 0 on the x-axis and 15 on the y-axis. So this is the point 0 comma 15, and next point is 5 comma 0. So this is the point 5 comma 0. So now let's plot the line by joining these two points. So now we are having the graph for both the lines x plus 2y less than or equal to 10 and also 3x plus y less than or equal to 15. And also we are having the non-negative constraints, that is x is greater than or equal to 0 and also y is greater than or equal to 0. Means both x-axis and y-axis we are taking it as a positive. Now let's find the feasible region. So if we take up the first line, that is x plus 2y less than or equal to 0, the solution region will be, since it is less than or equal to, so the solution will be below the line. So all the region which is below this line will become the solution for this line. Now if we take up the second constraint, that is 3x plus y is less than or equal to 15, the solution will be also this side of the line. Because this is less than or equal to, that's why we are taking this side of the line. Now let's mark the feasible region where both the solution regions are meeting with each other. So this is the feasible region. We people know that the maximum and minimum value or the optimal value always lies at the corner of this feasible region. So we will be pointing each corner point with a variable. I am taking it as A, B, C and D. If you are taking feasible region, A coordinate we have got it as 0, 5 and we are having B coordinate. From the graph we can learn that it is 4, 3. So 4, 3. Now the C coordinate will be 5, 0 and D coordinate will be 0, 0. Now let's find the value of objective functions on the point A, B, C and D, and let's understand what is the maximum and the minimum value of an objective function among all these points. Now we are having a table with points and its values on the objective function. Now substitute each point in an objective function in order to get the maximum and the minimum value. First we will be substituting A point, which is 0, 5. If you substitute A, we will get Z value as 10. Next, let's substitute B points, that is 4, 3 in the Z. We will be having 3 into 4, that is 12, plus we will be having 3 into 2, that is 6. So total is 18. Next, we will be having the value of objective function on a point C, that is 15, and value of objective function on a point T, that is 0. Now let's find out what is the maximum value of objective function in this table and also the minimum value. So we are having the maximum value, that is 18 for the point B. Now also we are having the minimum value, that is 0 for the point D. So Z maximum will attain, that is 18 at a point B of 4, 3, and also Z minimum is attained as 0 at a point D, that is 0, 0. So that's it, the answer for this sum.